exponential and radical forms, and then using that to evaluate or simplify expressions. So we are going to start by converting between the two forms. The way we recognize this is if I have some number or some variable to a fractional exponent, that's an a and not a 9. So say it's x to the a over b power. That a is the power or the exponent. That b is my root. So anytime you have a denominator and an exponent, that's the root or the radical that we're dealing with. The top one then is the power that we're raising our value to. So the way I would write this one is it would be the b root of x to the a power, which can also be taken as the b root of x, all taken to the a power. So it doesn't matter when we apply the power, the answer still comes out the same. Similarly, we can go from a root to an exponential. They go both ways, and depending on what form we need it to be in, it helps us to simplify it even more. So we're just going to practice this. Example A is I would, of course, like to convert this over to its opposite form. So if I give you x to the 1/6, that is the same as having a root 6 of x to the 1 power, which you could just say is the 6th root of x.
Is that a b or?
It's a 6.
Yeah, I accidentally wrote that one b as a 5.
Nice. How?
Okay, but Sam said so did I. So did I.
That is so odd. I love it. Do we see how I converted these? Do we, like, just like if we need to take the 4th root of something in our calculator, we plug it in as the number to the 1/4 power, because it's still the 4th root. We're just writing as an exponent instead of a radical.
Or does
Yes.
1 have 1? X have.
Well, x to the 1 is the same as x. So I show it both ways.
Oh, okay.
Just like 2 to the 1st power is just 2. Just means there's one of them. That's all.
Okay.
Some people like to write it, some people don't. I find it redundant, so I don't write it, but I like to show both ways.
I thought it was a good question.
That is a good question. Next example.
Oh, so that's it.
That is definitely just part of it, yeah.
We're
That was too
already
big.
almost done.
But I mean, like, you have an answer for that.
Yeah, that was it. So now I've given this to you in radical form. I would like for you to rewrite it as an exponential form problem. So I know I'm going to have a fractional exponent, correct? What root am I taking here? The 4th root. And then what's my power? 3. So this is w to the 3/4 power. There are a couple ways you could get here. If you find one that works for you, that's awesome. I'm going to show you another way you could have broken this down that would have helped you get here as well. Well, it's part of it. So I could have taken this and recognized that I was taking w to the 3rd to the 1/4 power. And then I know if I'm raising an exponent to an exponent, I multiply the exponents together. And 3 times 1/4 is 3/4.
This is just it.
So if you need to break it down like that, that's okay too. Because they do come out to the same answer. If you don't see this relationship right away, definitely take this avenue. Let's do another one. This is y to the 5/6 power. And I would like to rewrite this in radical form.
Oh, I messed it up. I switched it.
First thing I'm going to do is I'm going to separate this into 2 exponents. So this becomes y to the 5th to the 1/6 power. I recognize that the 1/6 power means a 6th root. So this becomes the 6th root of y to the 5th, or that could be the 6th root of y all to the 5th. Either one of those are correct for those final 2.
So we have to show the middle part.
This one?
Yeah.
No. I'm just breaking it down to its absolute minimum so you can see what's happening. If you see the connection already, jump right to it. That's fine with me. Questions, concerns, or issues with that one? We're going to do 3 more as practice, and we'll move on to the next part. rewrite that as a fractional exponent. Did you write all these already?
One.
I didn't write all of the examples, but I did the first two. Like I did like the
First two sections.
Yeah.
Good. Allison, what is this going to be as a fractional exponent? T to the 6 over 5. How did you know that the 5 had to be the denominator here? It was the radical, right? And then the power I was raising it to was the 6, so that had to be my numerator. So that is 100% correct.
Okay.
Yes.
Can you put a 2t to the 1/5? Wait, no, never mind. That was mine. I was thinking like fractions.
You also could have separated this if you didn't see this connection right away, and you could have rewritten this as t to the 1/5 to the 6th power, and again, they multiply, so it still comes out to be t to the 6/5. It's whatever connection you see is fine with me. Okay? Questions, concerns, or issues with that one? Let's do another one. Sometimes I love it when I write something that just looks beautiful. Okay, so this one doesn't quite jump out at me like the other ones have, so I'm going to use my separation method on this one. So I'm going to say that this is equal to c to the negative 5 to the 1/3 power because that's a cube root. I know I can multiply exponents together. So this becomes c to the negative 5/3. But I can't leave it like that because it's never simplified if I have a negative exponent. So what do we know happens if I have a negative exponent? Anybody have an idea? Say it.
Absolute value.
Nope.
You do that.
Anytime you have a negative exponent, it indicates that it moves to the opposite side of the fraction. So because this is present in the numerator, it has to move to the denominator to become positive. So that is equal to 1 over c to the positive 5/3.
That's weird.
So a negative exponent moves to the opposite side of the fraction.
And then does it make it positive?
Once it crosses the fraction bar, it changes signs. So yeah, it changes from a negative to a positive.
Even if the 3 was negative.
It doesn't matter because when we apply it, it can go to either. Okay, let's do one more and then we'll move to the second portion. Go ahead on your own and rewrite this as a radical expression. Xavier, what's it going to be?
I think I don't know what it's called, like this thingy.
Which, like the square root side, the radical?
yeah.
We call it a radical.
Yeah, and then I did the 2
Okay,
with the given inside and parentheses with the 3.
like that?
Yeah.
Okay, so he said that the 2 was my root, which I agree with. Does he need to have the 2 on the outside of the radical? Yes or no?
No.
No, he could. It's not wrong that way, but we recognize any radical without a number out front as our square root, so it means the same thing. Did he have to put that 3 on the outside as an exponent? Or could it also have been inside the radical? Okay, both of these would be equivalent expressions.
So it doesn't matter.
It doesn't matter where you choose to put it because they both mean the same thing. That was 100% perfect. Good job, Xavier. Questions, concerns, or issues,
Can
Sam?
we leave the 2 out there?
If you wanted to, absolutely. It's not wrong. It's just that we know when we see one like that, it's automatically a square root to us. Yes.
What would happen if it were to be a square?
Like,
If, say instead of the 3,
it was a 2/2
yeah.
kind of thing? Well, we could have chosen, so she's asking what if I had p to the 2/2 power? Well, we could have first recognized that 2/2 is just 1. If we didn't recognize that, then I would have written it as the square root of p squared. And what do I know happens if I have the same radical as I have exponent? They cancel, leaving just the p anyway. Good question. Normally, you'll see it like this, and you'll automatically know that it reduces. Same if we had like 8/4, I know that can become a 2. No need to do the extra work. Questions, concerns, or issues with switching between radical and exponential form? Okay, part 2. We're going to use this to simplify an expression with a number rather than a variable.
Yeah, I want to go back to the very.
Yeah, let's go back.
So here I have 27 to the 2/3 power. You're not just going to put it into your calculator. You're going to show me the conversion, and that's how we're going to solve. You could check it using the calculator. That's fine, but it will come out the same.
So this
So
is
we
the
could-
non-calculator.
This is
portion
the
of this.
non-calculator way.
So we just do the same thing.
Same thing, Shane. What is that going to turn into as a radical expression?
Give me 1 second.
Okay. You don't have to come up here. You can tell me.
I can't speak well.
Okay.
Hang on, you write paper. I'm sorry, Sam.
It's okay. What is 694?
Okay, so that's just beautiful. First of all, you need to be really careful how you write this, because to me that looks like 3 times the square root of 27 squared. I know it's not, but if I'm grading your paper and that's what you write, I'm going to count it wrong, okay? So this is the cube root of 27 squared. Is that the only way I could have written that? No, I also could have written it as the cube root of 27 squared, correct? Without a calculator, do you think it's going to be easier to solve it this way or this way? So option 1 or option 2?
Option 2.
Option 2. So there's a reason that we rewrite it like this, because some of them are easier to solve looking one way than the other. Why is this way easier to solve?
Because you don't have to, oh, because you have to.
I know the cube root of 27 is what?
Like
3. And then I can just take that answer and square it. If I have to square 27 first, I'm lost. Because I can't do that without a calculator. I mean, I can, but it takes a long time. Okay, so you can choose which way works best for you. So I know the cube root of, what'd you do to my board?
I didn't do nothing. I just handed you back that.
So I know the cube root of 27 is 3. So this becomes 3 squared, which equals 9. So the simplified answer here is 9.
Where did you get 3?
3 times 3 times 3 is 27.
Oh, I put 20.
Questions, concerns, or issues with that? If you had a calculator, you definitely could have squared 27 and then taken the cube root of that, and you still would have gotten 9. We okay? Let's do another one. I can already tell you guys love this so much.
I'm having too much fun.
No such thing as too much fun in math class. Okay, so now I have negative 16 to the 3/2 power. First thing I need to do is rewrite this as radical form. What's going to be my root here? 2, and we call that what? The square root. I quit. So this becomes a square root of negative 16 cubed, right? Or the square root of negative 16 cubed. Either one of those are the same thing.
16 cubed.
It doesn't matter which one you choose to do first. It really doesn't.
I'm just trying to figure out how to cube.
Well, negative 16 times negative 16 times negative 16. That's what it means. It's cubed, not cube rooted.
Uh,
So I'd multiply it by itself 3 times.
that'd be a way.
What's the answer of this one gonna be?
4.
2
Oh, I'm hearing like 4 different things right now. Take a second to really look at what I'm asking you here. Take a minute to really look at what I'm asking you here, and then I'm gonna ask again. On this specific problem where I'm asking for the square root of negative 16 all cubed, what would be my answer? I'm hearing negative 4, which we automatically think of, but it's completely wrong because negative 4 times negative 4 is positive 16. But I'm also hearing no solution. Why is this no solution? I can't take the square root of a negative number because no number times itself is going to be negative. No number in our real number system. And that's all we're dealing with right now is our real rational number system. Okay, so complex numbers do not exist here. We can't think of them. So I can't take the square root of negative 16, so this is no solution.
That was my favorite problem.
That also would work if I had cubed it first because a negative times a negative times a negative is still a negative, and I can't take the square root of a negative number no matter what it is. So this is no solution either way. Do we all see why? Let's do another one. You do get syntax error.
You did it fun. I should wrote that down.
You think that hasn't happened before?
Really? What do you do with it? Do you count it as wrong?
Well, if it's undefined, I don't give them full credit, but they're not wrong. Like they are wrong, but they're not wrong. At least I knew they knew how to plug it into their calculator. I mean, that's something. Okay. As I'm looking at this, what is the first thing that I need to acknowledge and work with? It's a negative exponent. So what do I know a negative exponent means?
You gotta do that thing where we count it down.
It moves to the opposite side of the fraction. Right now it's in the numerator. So that means it needs to move to the denominator and then it becomes positive. So now that is 32 to the positive 1/5 in my denominator. I can go ahead and rewrite that as a radical. So this becomes 1 over the 5th root of 32, which I can plug into my calculator and solve. What's the 5th root of 32?
I said we're not allowed to do that.
I said you are now. Oh, you could. I know the 5th root of 32 off the top of my head. I don't know if you guys do.
Teacher.
What is it?
2. It should be 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. That is 5 2s. Which makes it 1/2. Because the 5th root of 32 is 2. You can absolutely use your calculator on this. I just want to see the conversion process first. Because there may become a time where I don't give you a calculator and you have to do it freehand like this. Okay, I probably wouldn't give you something as high as a 5th root for something like that. You never know. If I did, my base would be 2 or 3. I guarantee it. Let's do one more and then we'll move on to the next portion.
There's another portion?
Of course.
But you said this was an easy fast one.
This is.
It's not. You're just too bad.
Sounds like my score list.
Okay, this one. You see there's 25 minutes left. That's perfect because we're halfway done.
Huh? It's gonna take the whole time.
No, we didn't start on time.
Wait, is that 125?
That is 125 to the 2/3 power. This is yours to solve on your own. Calculator. You may use a calculator, but I need to see the conversion as well.
I don't know.
Yes, you do.
I can't.
I'm just dropping everything in there. It's nice to actually teach something today, though. I've done nothing but I-step practice all day.
I would much rather do I-step practice.
You get to listen to me talk to you for 50 minutes. I don't think
I
you
would
would.
fall asleep. I would take a nice good.
No, you will not take I-step.
Yeah, we don't do I-step.
You have to take the SAT.
Yeah, I would much rather take I-step. I-step was easy. No, was it? I guess it was hard.
Okay, 2 minutes.
I didn't know how to do 97. I don't know how to put this in.
Well, you need to break it up first into its root and its exponent.
Okay.
Miranda, you seem very animated right now. Why don't you talk me through this?
Okay. So it is just the 3 and then the square root and then the radical and then the 2.
Where's the 2 going? Anywhere I want? Can I go right there?
No, it's an exponent.
On what?
125.
Okay.
Stop. And then so you take the cube root of 125 and that's 5. And then
Okay. That's not the way you do it for the way you've written it. So is there another way I could have written that? Okay.
Yeah, I did that as well. I just
You didn't tell me that. Okay, now keep going.
and then how to square.
So what'd you get when you took the cube root of 125?
It's 25.
Perfect.
Yay!
So you should have done the cube root of 125, just like Miranda said, and you would have gotten 5. Then we square the 5, and we would have gotten 25. You also could have done 125 squared, gotten a huge number, and then taken the cube root of that.
Okay, I got 20.
Any questions, concerns, or issues on this one?
How do you plug that into a calculator?
Which part?
Whole part.
Well, 125, then you do the upward caret arrow thing, and then 130 power, enter, and then square your answer.
Yeah, I did. So what I did.
Anybody not get 25 other than Brandon right now? No, we're all good? This super easy still? Yeah, okay. While he's working with Shane, let's do the next part.
I messed up.
Okay, I didn't do.
I was learning part 3.
And then
Part
you wanna
three.
move up,
I had part
or
on
move
there.
to the side,
4.
always to the side, and then move up, L,
She said
forward,
halfway
another point, see, and then you
during
go
the
to
second
five.
part.
Okay, how long is this
That
part?
could
You made that
mean
sound way
anything
harder.
that can even
I
happen
know.
with the examples. Therefore,
I have 6
section
examples for this part.
3
We won't do all
bigger
6.
Oh,
section 4. Therefore, yeah.
Simplifying exercise.
You broke your board again.
Ouch.
It's a sign. Stop here.
You might think it's a sign in a second.
oh wow, that's
Great. Just great.
Oh.
I can't do that.
Should have listened to it.
But we can.
You gotta see the rest I got.
So the beautiful thing here is I'm not necessarily looking for an answer. I'm looking for you to simplify what you've been given. So we're gonna learn another exponential rule here, which is really, really cool.
Is that a 4
That is a 4th root of 27, and then over the square root of 3.
Can we just cancel 3 and the 27?
Well, if I get that down to a base of 3, yes, but I can't guarantee that I can.
Just 3 and the 27.
Okay.
That's it.
Full number.
That's why I said maybe we're not looking for a whole number. The first thing we're gonna do is we're gonna rewrite these in exponential form because it's really easy for me to combine terms that have exponents in them rather than radicals. So the first thing I'm gonna do is rewrite the 4th root of 27 is 27 to the 1/4 power. And then square root of 3 is 3 to the 1/2 power. The only way I can combine these is if they both have the same base number. Right now, this one has a base of 27. This one has a base of 3. So I need to ask myself, is there any way that I can rewrite 27 with a base of 3?
Oh,
Divided by 9.
Can't divide anything out. I can just rewrite it using exponential form.
What?
Kick it out.
I started to hear it. 27 is 3 cubed. So that means this becomes 3 cubed to the 1/4 power over 3 to the 1/2 power. Of course, I need to simplify that numerator, so I'm going to multiply the 3 and the 1/4 together. So then this becomes 3 to the 1/4. Oh, sorry, 3 to the 3/4 over 3 to the 1/2. They both have a base of 3. They both have an exponent. So here's the really cool rule that we have. The first thing we do is we identify which exponent is larger, 3/4 or 1/2.
3/4.
3/4. So that is the term that is going to stay. The other one is going to move, and when it moves across the fraction, it becomes the opposite sign. So I'm going to subtract 1/2 from 3/4. So this becomes 3 to the 3/4 minus 1/2. Because I moved that 3 to the 1/2 up to the numerator. They combined, and we subtracted because we moved it across the fraction bar. So then this becomes 3 to the 1/4 because I know 1/2 is the same as 2/4. 3 minus 2 is 1. And then we're done.
So it equals 3 to 1/4.
So that equals 3 to the 1/4 power. That's your answer. Of course, if you wanted to, you could rewrite it as the 4th root of 3, but that's not necessary.
You made that sound way more different.
Sorry, I didn't mean to. The key here is once we get it down to the same base, we have to pick which one is larger exponent-wise. That's the one that stays. The other one is the one that moves. If you don't do it like that, it's going to cause extra steps. Okay, so we're going to do another one.
Just one more.
Oh, okay, more than one more.
2 more.
And
I just want
I wrote the whole note.
if you wrote, does anybody have this portion already pre-written?
Yeah.
No, you don't. Who does? You have this portion? No. Okay, this is example C. If you were to look at my notes, we're skipping B because it's not necessary.
I started writing it, but
You might hate me after this one, and I'm so sorry.
What if we already hated it and can't hate you after?
That's me.
Well, I wasn't expecting that. Okay.
oh my gosh.
That came out worse than what I meant to.
Thanks.
You want a hug,
Wow.
Instagram?
That's my
Oh.
Group hug.
Okay. As I'm looking at this, who has an idea of where we need to start?
The answer is 1.
Okay, cannot cancel the 2's because they're not being multiplied in. Good idea, though.
You cancel the 1/2. We don't need-
Can't cancel the exponents because they're not present in every term.
We can cancel the.
The -2 plus
Boom.
2.
You have to make them both equal 1, right? Is that what you-
How about I rewrite this, and then I think you're going to know what we need to do.
Wait, what?
So this is the, hold on, give me 1 second, just because I want you guys to see this.
Ooh, yeah, you can do that.
I don't necessarily have to do this, but I think it's going to help you.
Still must.
What do I need to do?
You need to conjugate.
Say it, Cadence. I need to rationalize by multiplying by the conjugate of my denominator.
Yeah, the negative.
This is what we did last class.
I don't remember last
I need to rationalize and get rid of the radical in my denominator if possible, which means I need to multiply by the conjugate of this. So what is the conjugate of 3 root x plus 2? Just minus 2. Good.
Oh, I'm blanking. Oh.
My brain went negative, but my math went plus. Wow.
As I can see, I'm going to have to FOIL out both the numerator and the denominator. I know that makes you so happy.
Yay.
Like you do that.
I can't control my excitement.
I bet you can't. From here, I'm going to work on the numerator first. Of course, I will do it because I think we might need a refresher, and that's fine. As I'm foiling this, I have 3 times the square root of x times the square root of x. What do you think that becomes? 3x, because the square roots cancel. Square root of x times -2 is -2 root x. -2 times 3 root x is -6 root x. -2 and -2 is +4. And that was just my numerator. Now I focus on the denominator. 3 root x times 3 root x becomes 9x. 3 root x times -2 is -6 root x. Positive 2 and 3 root x is positive 6 root x. Positive 2, negative 2 is negative 4. Give you guys a second to catch up.
Can you cancel numbers out?
Like these two?
Yeah.
Yes, they will.
Oh, like cancel.
Yeah. Okay, so from here, I look to simplify. I automatically recognize that these two cancel in the denominator, which is why I multiplied by that conjugate, because I knew it would happen. So my denominator becomes 9x minus 4. Is there anything that I can cancel in the numerator?
Now with the stuff you can add together, right?
There's stuff I can put together. Brandon, what can I put together?
The negative 2x and negative 6x.
I can put these two together, which means I just combine the numbers on the front, and then it'll have a root x as a variable. So that becomes 3x minus 8 root x, and then plus 4, and then we're done. Cannot simplify that anymore.
Oh, I didn't know,
Wait.
plus 4 was part of the,
Yeah, negative 2 times negative 2 is positive 4.
so I didn't know it was part of the.
Oh, yeah.
Yeah, it could have been a lot worse.
Because like we've kind of done this.
Mhm. That's the point. We build off of stuff we've already done. That's the whole point of math. Math.
I don't understand math. There's no point.
I like it.
You were just breaking my heart today. I mean, like full on breaking my heart.
I like the.
No.
So sad. Okay, so we're actually just going to do 2 more, and then I'm going to turn you loose. Okay?
The video.
I will. Yes, we will try.
We already watched.
We started it.
We're in the last.
I just
She's only talking loud.
Yeah.
What?
I
That would be so bad. It seems like. Multiply the 2, 7,
I lied. We're gonna do 3 examples.
I don't have one.
I cannot lie to you.
I'm gonna have one more. Is this the last one, or are we doing one more?
This one and 2 more.
Oh,
But this is the last section.
Oh, this was the last one.
Have I ever said how much I hate exponents?
You know, I didn't know.
Can I tell you they're never going away? Okay, Patty, you're up. Any idea of what we're gonna do here? Okay. So first off, we know that when we divide, we subtract exponents, right? What's the opposite of division?
Subtraction.
What's the opposite of subtraction?
Addition.
So when we multiply same bases, we add the exponents together. So since these are both in a base of A, I know my answer is going to be A, and then I'm going to add 2 7s and 4 7s together to get my new exponent.
Do something like
6,
that.
7.
So that's A to the 6 7. That's it.
That's crazy.
I thought you wanted to equal a squared. That's what I was just about to say.
Ah.
8 to the 2 7. Never mind.
Yeah.
That
Okay,
is
question.
the square.
What if the 7 is the same?
Ah, great question. Ask it again.
Okay, I wonder if the 7s weren't the same. Let's say we had 2 over 5.
How about we have
Oh.
3/4 and 1/2? Let's say that one.
You know what?
1 second, honey.
You're not allowed that.
I can try.
What's your question?
Wait, I don't understand why it's not a squared. You explained it to Megan, but
Because that's not A to the 1. That's A to the 2 7s and A to the 4 7s. So if I do A times A, this is just a side note. If we do A times A, we acknowledge that that's A squared, right?
Yeah.
But why is that A squared? It's because it's A to the 1 times A to the 1, and 1 plus 1 is 2. So we've been doing this all along. You just didn't know that you were doing it. So now we're just focusing and learning it differently because we're not doing whole number exponents anymore.
Keep tricking us until way.
Okay. So Shane had this wonderful question. He asked, what if my denominators are not the same? Does that mean I can't add them together?
No.
No. How do we conquer denominators that are not the same?
Figure it
We find a common denominator. Yes.
How do we do that?
Okay. So here I have a 4 and I have a 2. What do both 4 and 2 go into? 4. To make this 2 into a 4, I need to multiply it by 2, so I have to do the same thing to my numerator. So the 1/2 is the same as 2/4. So this is the same as a to the 2/4 times, a to the 2/4. And when I add those together, I get what?
A to the 1.
A to the 1, which is just going to be a.
Can this be the last one?
No, there's one more, I promise. And then that is it.
How do you say?
Which can be that one.
Yeah.
What is this?
Okay, how did we feel about that? You guys, I really do want you to refocus. I'm glad you're having fun, but we need to get through this, please. Okay? How do we feel about everything we've done so far? There's one more example, and then I promise we're done. Okay? There's always fuzzy parts. That's what I love about math. Okay, this is the last one.
Whenever I write them out before coming in here, it looks so nice, and I write them out while you're going, and they look
My notes have never been.
Okay, do you want to see it? I can't even read my own.
that's. What is that? Wait a minute.
Okay. Oh my
Wait,
God.
cross multiply.
Nope. We cross multiply if there's an equal sign between them, but there's not.
Can we put
I do not want to have to make a new seating chart, ladies. Please don't make me.
Are we gonna rewrite it?
We're gonna rewrite this. So as I'm looking at it, I know the first thing that pops into your head is cross multiplication, because we see these two beautiful diagonals that we could multiply across. So that's not how it works if there's not an equal sign between them. When we're multiplying a fraction by a fraction, we multiply straight across. So this is the same as b cubed times c over c to the 1/2 times b to the 1/3. So it really didn't help us at all. We still have the same issue. I have a b on top and a b on the bottom, and I have a c on top and a c on the bottom. That can't happen if I'm simplifying. I can only have one of each variable present. That's it. Nothing else. So the way this works is if there were any repeating b's in the numerator, I'd put them together. If there were any repeating c's anywhere, I'd put them together. Since I have ones that are across the fraction bar, how did we simplify earlier? When I had, say, an a on top and an a on the bottom. I picked the one that was biggest, and I subtracted the other one from it. So we're going to treat these two separately, and then you'll see how it comes together. So I'm going to focus on the b terms first. So I have a b cubed in the top and a b 1/3 in the bottom. Which of those exponents is larger? The 3. So that one's going to stay, and I'm going to subtract the other one from it. So this becomes b to the 3 minus 1/3. Of course, I can't just subtract a whole number and a fraction. I need to change that whole number into a fraction with a denominator of 3. So 3 is the same as what over 3? 9. So I'm going to change that. And I know that that specific term then becomes b to the 8/3. Are we all okay with that? And that's in my numerator. So I'm going to put an n in parentheses by it, so I know that means the numerator. I'm going to do the same thing then with my c's. I have a c in the top and a c in the bottom. Which one has the largest exponent? The top or the bottom? But there is no exponent on the top.
Exactly. One.
But it's a 1. Good. So that 1 is bigger than this 1/2. So also in my numerator, I have a c to the 1 minus 1/2. Of course, I know that 1 is, you can't just subtract a fraction from it. So I need to change it into a fraction with a denominator of 2. So 1 is equal to what over 2? 2. So that becomes 2 over 2 minus 1 over 2, which equals what?
C 1/2.
C 1/2. So that means my final answer is b to the 8/3 times c to the 1/2, both in the numerator. And then we're done.
So if it was on a denominator, would you just put it all over?
I I would put it under, like, if those were in the denominator, it'd be 1 over that.
Yeah.
Yeah, we'd put 1 over all of it, yes. You said that over 1, which is a big difference.
Okay, that's
Yeah.
what I meant.
Yes. So she asked a really good question, and I think it is something you guys might run into. If those had both been, like, had to go to the denominator, my numerator would have been a 1. Okay, you can't just put a 0 there or act like it doesn't exist. If there's nothing there, we assume it's a 1. Okay, your homework is on Canvas. I believe it is 10 questions. It won't take you all that long. I'm pretty sure.